In this video, I'm taking a look at a 10.1-inch display for the Raspberry Pi. So I'm breaking this up into 4 sections. In the first section, I'm going to briefly describe what this is. Then I'm going to do a little bit of reverse engineering and determine what components they're using and how everything works. Then I'm going to skim over the documentation, and then finally I'll give my thoughts on it. Hopefully this will help you make an informed decision on whether it does what you need it to do. So this is an interface board for the Raspberry Pi that also works as a monitor for other devices. It gives you a 10.1-inch touch display with stereo audio. I tested it with Windows and I was able to just plug it in and Windows installed the touch drivers automatically. I also tested with the Raspberry Pi and that process is pretty straightforward as well, starting with first installing the Pi and then adding their custom HDMI and USB connectors, and then finally copying some things to config.txt to configure the display output. Now let's talk about how everything works. I'll start by looking at the display. It has a 1024 by 600 resolution screen with a touch panel attached to it. The panel is the SH010JG-I55 and it uses the DPI interface. It isn't getting that DPI interface natively from the Raspberry Pi though. Instead, it adapts DPI from the HDMI signal using this chip, the RTD2660H. The chip has 2 HDMI inputs, one for the Pi and one for an external device. To the left here are a few other components that this chip needs to function, including what I believe is an EEPROM that stores the settings for the HDMI chip. The display has a touchscreen, and touch is handled by this IC. It connects directly to the USB port on your Windows or Linux system and interfaces it with the touch controller chip that's on the LCD cable. It takes that data from the touch controller, which is sent using I2C, and sends it to your operating system using USB. It doesn't have any markings, and I wasn't able to identify exactly what this chip is. It could be a microcontroller, or it could be some other special purpose chip. I just couldn't find anything definitive, and the manufacturer refused to give me any schematics for the board. The board is able to receive power from the Raspberry Pi that's attached to it. It comes with multiple adapters that plug into the various different Pi versions USB connectors, and the adapter supplies power and also creates the USB connection for the touch panel. In my testing though, the USB power is not great. There's a lot of voltage drop on the USB cable going to the Pi, and then there's more voltage drop between the Pi and the display board. And no matter what I did, I had constant problems from the voltage being too low, both on the Pi and on the display board. This was very easy to fix though. The board has 2 additional USB ports, one for power and data. Running an extra USB cable from your power source to one of these extra ports will take care of the voltage issues, because all 3 USB ports connect to the same 5-volt bus on the board. One word of caution though, both ports labeled touch connect to the same pins on the touch IC, so you can't connect more than one data device at the same time. That 5-volt USB input voltage is increased and decreased at different parts of the board for the various components. Here it goes into 2 buck converters that create 3.3 volts and 1.8 volts needed for the various things like the HDMI chip and some of the LCD components. And this group of components is the boost converters, which create the higher voltages for the LCD and the backlight. Now on to audio. Stereo audio is provided digitally from that HDMI chip that I showed earlier. It then goes into a CS4334 digital to analog converter, which turns it into analog audio. That audio then goes into an APA 2068, where it gets amplified for the speakers and headphones. Alright, now I'll take a quick look at the documentation. It came with a setup guide in the box, and it gives a list of features and package contents, and there's enough information here to get up and running, including the config.txt info for the Raspberry Pi. And finally, onto my thoughts. The build quality of the board seems fine, and I didn't notice any issues with component placement or solder joints. For the most part, they seem to have used components with readily available datasheets, which I'll provide in a link below. Their choice to go with HDMI and adapt it to DPI keeps all the GPIO pins available for other things, so that's probably a positive for most projects out there. My camera can't do it justice, but the display quality is pretty good. A 1024 by 600 resolution is definitely an improvement over the similar 800 by 480 screens. It's nothing compared to 1080p, but it's fine for what it is. The touch panel works fine, but it's very easy to scratch. These scratches shown here happen just from normal usage, mostly when I set it down onto this wood table for filming. I had some issues with the smoothness of the frames when I tried gaming on the Raspberry Pi. It seems there was a stutter or jitter that I don't think was caused by the Pi, and maybe it's something with the timings on the HDMI chip. I didn't notice the same issue when using this with the Windows computer on the external HDMI port, so I'm not sure whether the issue occurs there. I also didn't spend much time investigating this. The audio quality is fine, definitely not exactly great. I added a short demo of the audio at the very end of this video if you want to listen to it, and it also shows what happens when you don't give this board its own 5-volt power source, separate from the power going to the Pi. Overall, it's perfectly usable, but only if you use that second USB port for power. Otherwise, the audio will cut out when the voltage drops on the board. And that about covers it. Thanks to everyone for watching, and a big thanks to you guys supporting on Locals and Patreon and through purchases made on my website. Have a good one, guys.